Welcome to the first presentation for Engineering 312, Engineering Graphics. So this is a drawing class. Most of the semester will be drawing, like pretty much all the time, but there is some additional material that's not strictly drawing. Things like the nature of engineering, the role of the engineer, the education system, things like that. So I'm going to try and be as brief as possible. I'll go a lot faster on this video than I would if we were in person. And feel free to use this material however it works best for you. I'm going to also post a PDF version of this same material, and you can watch the video in double speed or half speed, or you can look at the PDF and go as fast or as slow as you want. And try and absorb the material, but there's specific instructions on what I'm asking you to turn in, and so use those instructions as your guide for watching this stuff. Okay, so let's just go through this stuff. So this is the agenda here. We've got what is engineering and what do we do, what is not engineering, the education system, this particular class, and a little bit about a proper engineering attitude. All right, so what is engineering? Okay, now on this slide here, I've highlighted or made red a couple of words that sort of stand out to me. There's I'll just read those red words. Discipline. It's a field of study. We use the word discipline about to mean a body of knowledge or a field of study. It's a profession, okay? I mean, there's three words: technical, scientific, and mathematical. Okay, those I think is a good way to break up engineering. We use science, okay? You have to take a lot of science classes if you're an engineer. You have to take a lot of math classes, but you also take engineering classes that are, they use the science and the math, but they're not strictly science or math. They're engineering. They're technical, okay? So we use technical, scientific, and mathematical, and basically, we're taking the laws of nature and applying those to solve certain problems, right? That is, there's a practical objective, right? We're trying to solve a practical problem, and those solutions to those two practical problems take the forms of structures, machines, devices, systems, and processes. Okay, so that's one definition of engineering. You've probably heard others, and in the homework, feel free to put other interpretations that you've heard. All right. So what do we actually do? We design and create. Okay, technology. Design and create technology, and we act as leaders. All right. So that could be summarized as two sentences. We do the new stuff, okay, and we lead technology. Okay, if it's not new, you don't really need an engineer, and also if it's something new, it needs to be led by somebody, and that ideally that leader should have a broad base of knowledge, an engineering education, right? So that's one way to look at it, what engineering is. All right. There's lots of different kinds of things that engineers do material structures, machines, devices. I'm sure you can think of many. A lot of people, first thing that might pop into their head is a car. Of course, that's a machine, but there's many other kinds of machinery that the average non-engineer might probably wouldn't think of. There's in a car factory, there's thousands of machines that make the car. So there's the machine that makes the machine is a phrase that is often said. So there's systems. There's plumbing systems. There's heating systems, power plants. There's refineries and chemical plants, refrigeration systems, all kinds of things like that. Processes, there's making steel, making glass, making concrete, making lumber, these are all processes. There's materials, steel, building materials, wood, plastic, there's all kinds of things. You're surrounded by technology, and engineers are involved in the creation of probably most, if not every, new kind of technical thing, right? Then how do we do that? Well, we apply the tripod, I like to say, of science, math, and engineering, or science, math, and technology, or technological knowledge, or engineering methodology, you could call it. Science, math, and engineering methodology. All right, it's sort of a tripod of things. You take science classes, you take math classes, you take engineering classes. Let's see. This slide here is really just to make the point that engineering is a very broad-based field, and you can, once you get the degree, or even if you don't finish the degree, once you have some engineering training, you can apply that to a lot of different kinds of things. All right, that's just the point of this idea. You're not limited, to just doing design, or you're not as limited as many people would think. Okay, let's see. So the point of this slide is to kind of differentiate between the new stuff and the not so new stuff. So I like to think of engineering as solving new problems and creating new things. And I like to think of, just to use the term drafter, which is not it's not a totally accurate term, but what I mean is technical people that are perhaps less trained than an engineer, technical people that have less education. Let's use the term drafter for that. But those are more support people, and they may combine existing knowledge and keep track of that knowledge, whereas an engineer would maybe generate a little bit of new knowledge, perhaps. So, for example, like if you're building a house, most houses you don't need an engineer. All the stuff has been figured out, like the trusses, the thicknesses of the walls, all of that has been figured out by an engineer and written down, and you don't need the engineer at that point. You can just assemble the pieces using, you have to follow the code, right? That's been figured out ahead of time. So what the main point here is that engineers have a body of knowledge and skills that allow them to solve new problems and create new things. I think, to me, that's the core of what engineering's about, right? And it takes a lot of training and knowledge to get good at that kind of new thing. All right. So here I have a series of slides just to get you thinking about the kinds of things that engineers do. This is an iPad, and the idea here is you start with nothing and create an iPad, or you create this cool looking plane, or this jet engine, or here's a hip implant, just to get you thinking about how engineers are involved in more than just cars, right? There's a lot of technologies, any kind of technology really. There's going to be a role for an engineer in it. This is a piece of farm equipment. Looks like a tomato harvester or a cucumber harvester. This is a strip mining shovel that's one of the largest, maybe the largest in the world. Here's a windmill. Here's a novel looking solar thing. And this is one of those cars, for the supercars or whatever you call it. But the point of these slides is just to get you thinking of the breadth of engineering, that it's more than just something obvious that you might think of. There's lots of opportunities. Here's a small nuclear power plant, about a little larger than a human. And the idea here is you could have many of these in smaller nuclear power plants instead of a large one. Anyway, just to get you thinking about the breadth of the field, all right? This is, I don't even know what this is. Here's a bridge, of course. Engineers work on bridges, right? Another obvious kind of thing. Oh, this is that bridge that they put in front of the Hoover Dam, which is just one of my favorites. I think it's pretty, and it matches the sort of 1930s Art Deco look of the original Hoover Dam. This used to be, or it might still be, I'm not sure. This is an underwater robot, mostly used in the refinery business. This was a local company. Pretty cool underwater robots. They examine wellheads and pipelines and things that are for offshore oil extraction. Let's see. Oh, this was a company that was in Reno that has since gone bankrupt, but they were working on an advanced battery, lithium-ion battery. But that was before their time. There wasn't a demand for this kind of battery at the time, and they ran out of money before there was a market for this stuff. So they were just a little ahead of their time. But this was a local. If you consider Reno local, this was a local company. This is a Boston Robotics robot. You can look them up, Boston Robotics, pretty cool stuff. This was a local company, and I think they might still be around with a different name. But anyway, this is a hydrogen fuel cell thing. So it has a tank of hydrogen, and it generates electricity. And it's kind of, you can think of it as it serves the role of like a battery would, but it lasts a lot longer. So it'd be for something like a traffic light or something that was way out in the middle of nowhere, far away from the power grid. And this with a hydrogen tank of hydrogen, this would run for, I don't know, weeks or something. So it's like a battery, but runs for a lot longer. This is an ultrasound company. Volcano is also a local company. They make ultrasound equipment. Here's some people in Auburn that make these electric car power charging stations. So the point of all of these slides that I just went through is just to remind you of the breadth of engineering, that any kind of technology that you can think of, there is a role for engineers. It's not just about cars, bridges, houses. There's lots of stuff. And that's really important to think about, because there's so many jobs out there, but most of them are for companies that most people never think about. That is, one way to say that is that, like this, most people work for companies that nobody has ever heard of. And that's the truth. That we've all heard of the large companies, Intel, maybe Hewlett Packard, General Motors. Everybody's heard of those. But most people don't work for those companies. Most people work for small to medium-sized companies, and that's true for engineers as well. So if you want to work in engineering, you need to be thinking broadly about technology and be open to all of these different kinds of things. And there's lots of opportunity if you think about it like that. All right? So let's take a little turn here. Do we really start with a blank piece of paper? No, we don't. In fact, we never do. We most of the time we build on or extend existing technology. All right, just keep that in mind. There's a large body of knowledge of engineering that we start with. You don't just build a plane out of nowhere. You start by looking at existing planes, or for the case of the Wright brothers, they looked at things that were, as close to planes as they could, and well, that was a lot of new stuff. But they looked at birds and bicycles and kites, and somehow got a plane out of that. But they didn't start with nothing. All right, so we've all heard that there's lots of different kinds of engineers. There are. All right, there's the main ones: mechanical, civil, electrical. Those are the main ones, and computer is probably one of the main ones now, but that's less understood. because it takes a long time for, I don't know, popular society to catch up with things. But there's lots and lots of computer engineers. In the last couple of decades, they've put out zillions of them. So computer engineering is a very large subfield of engineering that's not thought of. But there's other ones, smaller ones. Chemical is big, and aerospace, and do your research. I would say here that if you're not sure what kind of engineer to be, it doesn't really matter. Pick one. And life is a journey. You're going to go off and get a job somewhere, or you'll have opportunity in school and after school to change what you've chosen. So don't even worry about it. Just pick something that keeps you going now. Pick something that's interesting to you now and will keep moving you forward. And don't worry so much about changing. There's lots of change in life. I never thought I was going to be a professor. It's just life is funny like that. All right. But another thing I would say about this is, sometimes it's better to have a broader based specialty than a narrow one, because, for example, if you pick biomedical engineering, for example, that's a much smaller than computer, for example. So you may find it harder to get a job. You might have to move. You're more likely to have to move if you have some niche type of thing. But if you're mechanical, then you have lots of opportunities, for example, or electrical, you have lots of opportunities. You're not so limited. Okay, but there's lots of fields. Do what's interesting to you. All right, so engineering is interdisciplinary. There's like one way to think of it is, let's take Intel, for example. If you don't think much about it, you would assume, and you'd be correct, that they hire a lot of electrical and electronics engineers and computer engineers. That's kind of the first thing that might pop to your mind. But keep in mind they also hire mechanical engineers, because there's heat transfer, and there's machinery that makes the chips. There's the actual size and shapes of the electrical components, and those are all jobs for mechanical engineers. Okay, where also, or likewise, something like Aerojet, I'm not sure if they're actually still in business, but Aerojet hires, well, obviously you would think of aerospace, but they also hire mechanical and chemical engineers as well as structural engineers. So just pick something that's interesting to you that will keep you moving forward. That's the point there. And another point, let's say you're interested in the environment. Well, you might want to study environmental engineering. Maybe that's a good choice, but just straight out electrical engineering may provide you a whole lot of opportunities, because there's a huge impact in power generation on the environment. So if you're an electrical engineer and you worked at PG&E, you may have an opportunity to affect the environment in a much bigger way than if you studied something smaller like environmental engineering. So these are just things to keep in mind. You need to talk to a lot of people, and a lot of different kinds of engineers and different professors and counselors and your parents, and talk to everybody and get lots of opinions and make up your mind on what you want to do. So what's this class about? Well, we have two main goals. We're going to learn engineering problem solving using graphical methods, okay, because this is a graphics class, and engineers are all about problem solving. That's one of the main things we do. Okay, so we're going to learn the basics of problem solving using graphical methods. And the second thing is how to communicate technical information via graphics. Okay, so it's problem solving and communication. Those are the two main things. So as far as the communication part, there's standard ways to draw things that other people that are similarly trained will understand right away. Okay, and the engineering problem solving, well, you'll see. That's hard to explain in a few sentences. Okay, so let's see, tools to create. Well, engineers create, so we need creativity. That's good, and my personal opinion on that is that everybody has a certain amount of creativity, and maybe you can get better at being creative, maybe you can't. I'm not really sure, but we certainly need creativity, but we need some other things as well. So we're going to concentrate on those other things. And those other things that we need are things we learn in engineering school. Okay, so how does that break out, right? What is engineering education all about? Well, to call yourself an engineer, like to say I'm an engineer, you typically need a 4-year degree. There's also licensing, but there's professional licensing. That's more important for some kinds of engineering than others. Like if you're going to be involved in construction, or then licensing is more important. But if you're working for a big company, a lot of times licensing doesn't mean anything. But you do need a 4-year degree to call yourself an engineer, and so it takes 4 years. But the first 2 years of most engineering, if not all, is very similar. Okay, and so the first 2 years of engineering is mostly math and physics, and there's a little bit of chemistry in there. And so you really need to make sure that you're on track with the math. And the physics. That should be your number 1 and 2 priority, is math and physics. And then where possible, the next thing is squeeze in some engineering classes like graphics, and digital logic perhaps, and circuits and statics. All of those are taught at the community college. The first 2 years of engineering is you can take at the community college. And I think, while I work at a community college, but I happen to think that community college is a really good place to get those first 2 years. But you're going to need to transfer if you want to call yourself an engineer. 2 years is not enough. If you have 2 years of training, you mostly have the math and the physics, and you have a little bit of engineering, but not that much. And your 3rd and 4th year of college in engineering, you're going to get lots of engineering courses. Okay, so you have to have a little bit of faith, okay, in the process. It's the engineering education process is not perfect, but it's what we got. It's the best we got, and it does work. So to create, we need tools, and you can think about engineering education as filling your toolbox, right? So one way to think about it is, if let's say you like shopping at the tool store, I do. That's fun. It's fun to buy wrenches and screwdrivers and things, but maybe welders, but it's much more fun to make things with those tools. So engineering education is like that. A lot of the courses, some are more interesting than others, but you need to have a little faith that when you graduate, that you'll have the opportunity to apply those courses, to apply the knowledge that you learned in those courses towards creating real things in the world. And that creating real things is a lot more fun than learning about how to create those things. It can be. So you need to have a little faith and perseverance and stick with the program. And think of the courses as just preparing yourself for when you get out there. All right? Okay, so who should take this class? Well, it kind of breaks out to a couple of groups. There's some of you that are already committed to majoring in engineering. You're going to graduate in engineering no matter what. Okay, there's that group of students. And for you, I want to mention there's a website, www.assist.org, and you really need to check that and use it as part of your planning, and not exclusively, but as another tool for your planning. You should also be talking to your instructors and your counselors and your parents and people that you know. But Assist is an important tool. Check it out. Then there's people who are interested in working in an engineering related job. That's another group of people that find their way into this course, and you're welcome to be here. And then the third group is people that maybe are less committed but are just curious about engineering, and you're welcome here too. You're in the right place, okay? So all of these groups, from people that are super committed down to people that are, still exploring and not as committed, everybody's welcome, and this is a good place to explore engineering for everybody. And this course does articulate to most engineering programs. So if you're committed and you're going to be an engineer no matter what, then most likely this course will help you. Now that depends on your major and some other things, so you need to check with assist.org on that, as well as counselors and other people. All right, what are we going to do in this class? We're going to draw. We're going to learn some problem solving methods. We're going to learn some drawing standards. That's the communication piece. That's pretty much it. We're going to use some 2D and some 3D software tools. Basically, we're going to use AutoCAD and Fusion 360. We were using Rhino for a while, but we're not going to use that anymore, I don't think. Maybe, but I doubt it. Let's see. Then there's some other topics that we need to squeeze in. There's a little bit on materials. There's a little bit on tolerances, some different notations, and you need to get some exposure to finite element analysis, and a few other things that are not strictly drawing, but they fall into this class. Let's see. So how does the class work? There's some lecture like this one, and then there's videos on how to get the thing done, and so I make some videos and show you how to do that, and then you just draw. So it's mostly lab, and with it being online, you're basically going to watch a video on how to do something or on some theory, and then you're going to either write something up if it's a theory, or you're going to draw, and that's how it works. So I encourage you to help each other, but do not cheat. And cheating, well, what is cheating? Well, sharing files is cheating. Okay. Helping each other by explaining details of how to do something, that's okay. So, your stuff should look different. Now, because this stuff's online, I'm not really sure how the helping each other is going to work, but if you can help each other without cheating, then that's good. Do your best. Let's see. I'll be looking at your stuff and trying to give you feedback as much as possible. Yeah, we're meeting online, so normally attendance and participation are super critical for this class. With the online format, we'll just have to do the best we can. Okay, the very last thing is something about attitude. So let's see how to think of this. Well, engineers are professionals, okay? So other kinds of professionals, or that people think of as professionals, are doctors, lawyers, and clergy. Okay, those are professionals. There's lots of other kinds, but those are the main ones that people think of. So engineers are some kind of professional. What does that mean? Well, to me it means that we're serving. Like, that's what it means to me. It's not so much about personal gain, although you will be rewarded for what you do. To me, what I mean by professionalism, it means a lot of things, but one of the things that stands out to me is that it means that we're serving the public good. Okay, the technology that we create serves mankind. It makes the world a little bit easier, a little bit, hopefully, better. But we're trying to solve problems that help people. Okay, and we're creating new things. And the thing about attitude is that we're concerned with what is possible. So if you're creating something new, and you have this sort of underlying attitude that it can't be done, you're less likely to actually be successful. You need to have a positive attitude. Now, it may turn out that what you're trying to do actually is impossible. That's possible. It's possible for it to be impossible, but you can't start the problem with this kind of negative, impossible attitude. You have to be thinking about what's possible. And then you need to do sometimes they call it first principles thinking. You need to go down to the physics and do some calculations and find out, is it in fact possible? And if it is, what's it going to take to get it done? You need to do that. But so you need to be realistic and use science, as they say, believe science and all that. But you also need to have a positive, like, emotional attitude, but be realistic about things. Okay, so that's really important. Okay, I think that's pretty much it. This last slide is just don't cheat, and so your drawings. Yeah, I will fail you. I will fail you if I catch you cheating. I mean, if it's just one drawing and I catch you on it, I might, I'll probably just give you an F for that drawing. But if I see a pattern of cheating, then I'll fail you. Okay, I've done it before, and I don't like to do it. It makes me sad for a long time, but I'll do it. So just don't share files, all right? Just you can use other people's, assistance in different ways, but don't share files. That is, you can explain how to do something for somebody. Maybe you could send a screenshot of something to somebody so that they know how it's supposed to look. But you know what a screenshot is. It's not the source file. It's just what shows up on your screen. Something that they would still have to actually recreate. Okay. So do your own work. All right, I think that's the last slide. Yeah, that's it. All right, so I hope this material was useful for you. Look at the instructions on assignment 1 on what I'm asking you to do, which is pretty much a write-up of these slides, a sort of brief, condensed notes from these slides, and then I'm asking you to go do some research on what engineering is and write up a little bit on that. So go see the instructions on that. All right? Thanks. See you next time.